Okay, we got questions that have come to us. We love your questions. We love it whenever we get them because it gives us a launching pad to be able to just go off on tangents and be able to answer questions that are really kind of cool and important. Today I've got Eric with me. Eric, appreciate you being here.
Yeah, Joe, excited to be here. I always enjoy coming and getting to talk about what our clients are experiencing and share real world stuff, if you will, to things that apply to all PA46 owners. So I'm excited about it.
Hey, before you ask me a question, let me ask you a couple questions?
Yeah, certainly.
It's the end of, right before Thanksgiving, end of November. What's the market look like for piston PA46s? And I'm going to ask you about turbines next.
Yeah, pistons have been a little bit slow at the end of the year, but I think picking up for the last probably quarter of the year. So I do foresee that we'll sell a few more pistons to close out the year. And so it's a good time to buy a piston, that's for sure. Lots of good airplanes available.
Yeah, the market's full of good piston airplanes right now. I think there's been a lot more turbine buyers, but it seems like the piston went into a little bit of a lull, but I think people are realizing, hey, this is a great airplane.
Yeah, certainly coming out of the lull.
Yeah, so we've had a couple good Continental airplanes that have sold quickly, that people like those. And we've had a couple newer pistons that have sold. It seems to me the ones that are lacking is the Mirages that are older, the 90s Mirages and things of that nature.
Yeah, anything in that middle tier of Mirages, 90 to 2000, 2005, somewhere kind of in that early 2000s is it's the struggle is there.
Yeah, let's talk about turbines.
Yeah, turbines are as hot as they get. You can't hardly look left or right without a turbine closing.
Yeah.
So the turbines have been very hot to close out the year, and I foresee that it'll continue with that pattern.
Yeah, I would say comparing the Meridian to the jet prop, do you get more like we have a 2006 2006 Meridian on the market, Avidyne. Good airplane, and we're getting a lot of phone calls on it. We've also got jet props that just not as many. Am I saying that right?
Yeah, and I think it's a case by case basis. A lot of the guys, I think the hot buy today is to take a early Meridian, anything pre G1000, and put the Garmin panel in it. And so we're seeing that more and more and more. And I think the Avidyne Meridian right now is probably the best buy in the market.
Yeah, yeah.
It's just a great value to get into the turbine, and you can make it a fully Garminized airplane for several $100,000 less than a G1000 Meridian, and I just think that's a big win.
Yeah, I do too. I also think, and this is weird, but if you listen to Warren Buffett and the people that know what they're talking about in the investment world, it's buy low, sell high. Jet props right now are on sale. Basically, there's not as many people want them. I think there's some reasons for that in terms of questioning of factory support. When you compare it to Meridians, Meridians are very hot. Jet props are a little bit on the lower side, but it's still I love the jet prop, which makes those at a tremendous value at this point. I think people that are buying a jet prop, probably a good time to buy.
Absolutely. I don't think you could have said it better. I think the jet props right now, people often say, can I sit behind a piston or that's newer, or should I sit behind a turbine? If I get asked that question, it doesn't matter what the panel looks like. I'm sitting behind a turbine every single time.
Correct.
And it's just that good.
That's right. And I think there's some buyers out there that when they look at, can I get into a turbine? The answer is, if you're flying a $500,000-$700,000 piston airplane, and you want to make the turn into a turbine, the answer is going to be, the jet prop's going to be the most reachable at that point. Meridian's going to take a little bit more. Meridians are going to take 7 figures to get into a quality Meridian. Yeah. You're going to spend $1 million.
Yeah, good Meridian's certainly over $1 million. $1 million to 1.1 is a kind of a good entry point into a Meridian to have in your head. In a jet prop, you can enter the jet prop realm in the 800,000 mark.
Right.
And so if you look at a $800,000 or $700,000 piston, your cost per hour in the jet prop's probably going to be cheaper.
Right.
Now the big ticket items are going to be more expensive if they happen, but cost per hour is probably going to end up being cheaper for you.
Right. I think that's accurate. Good.
All right. We love getting your questions. And so let's get started. All right. We had a customer that had just gotten his airplane out of a maintenance event, and he was having a cabin that was climbing a little too fast, faster than normal, what he had pre-maintenance event, pre-annual inspection. And he thought he had a pressurization problem. He brought that airplane to us into our Casey Aviation Services shop, and the team got after it. Can you talk a little bit about what the diagnosis ended up being with that?
Yeah. It was kind of an interesting study if you look at it, because the client basically made a report that, hey, the cabin's climbing too quickly. It's not pressurizing. And there's a couple things you want to think about as you think about pressurization. Pressurization is where we're uncontrolled. We're allowing air to come into the airplane. It doesn't matter if piston or turbine, doesn't matter. Air is coming into the airplane from either the turbochargers or the turbine engine through bleed air is coming into the cabin. And then what we're going to use is the outflow valve to control the air that's leaving the cabin. So we control the exiting air. We have uncontrolled air coming into the cabin. Okay, and then that leaves you with the cabin in what's called isobaric control. Iso meaning one, baric meaning pressure. So or iso meaning equal. So equal pressure. So you've got one pressure. In other words, it stays the same. The pressure inside the cabin stays the same when you're under isobaric control. Okay. With that being said, we control that isobaric pressure with the air that's leaving the cabin. Now, how does the cabin know what pressure to remain at? And the answer is you have a cabin altitude controller. So the cabin altitude controller, let's say you just set that cabin altitude controller at 7,000 feet and you take off from anywhere west or anywhere east of the Rockies. In other words, low altitude. Well, that means your cabin's at a lower altitude, and as you climb, the cabin is going to do its very, very best to get to 7,000 feet. That's the cabin altitude it wants to hold. Then the question is how fast is it going to go there? So what happened on this one, and I'll let the cat out of the bag if that's acceptable to say, is the rate controller, that the pilot had the rate controller all the way clockwise. Now, how did this happen? It probably happened during maintenance. In other words, the guys were doing an annual. They were touching everything in the cockpit, moving things around. Somebody's hand probably hit the rate controller and turned it all the way clockwise. It's easy to do. Matter of fact, it's easy for a pilot to do that is moving things around the cabin. Say moving hand. And so what ended up happening is the pilot had the cabin rate controller, has a little arrow on it.
Just the little knob. It doesn't have anything else but a little arrow on it.
It's a little arrow, and that's your rate controller. And when you think of the word rate, you want to think of something compared to time. So if you say the rate, what's your rate of speed? It's 55 miles an hour.
Right. And in the cabin rate, you get a feet per minute climb.
Feet per minute climb.
And it'll show you that.
That's right. So it's how much are you going to climb or descend? So the arrow is determining that. If you go all the way clockwise, your cabin's going to climb virtually as fast as you can.
Speed, yeah.
Yeah. And it's usually over 2,000 feet a minute. If you have it all the way counterclockwise, then it's going to climb very, very little. And matter of fact, if you really get down to it, it's really what we call a needle valve. Like if you took an orifice or a hole and you had a device and you can move that in and out, then it's like a needle valve if you think of it. Go look up needle valve and you can. When you have it all the way clockwise, you're taking the needle valve and moving it out. When you have have it all the way counterclockwise, in other words, turn it all the way to the left, you're shutting off the air that's moving through the controller. And so in this case, the pilot accidentally, because he's never touched the rate controller before, fairly new to the jet prop in this particular case, had it all the way clockwise. So when this pilot climbed up and had his altitude pre-selector set for, let's just say 9,000 feet, because if you're going to 27,000 feet, you're going to put it somewhere around 9,000. And the cabin basically said, hey, go to 9,000. So as he climbed, there was the thought in his mind of, my cabin is not pressurizing.
My ears are popping and you feel the systemic.
Yeah, because as I climb at a couple thousand feet a minute, my cabin's going at a couple thousand feet. So he's saying my cabin's not pressurizing. It was like, well, what could be wrong with this? Well, he brought it back and we looked over the airplane. And the bottom line is no one looked at the cabin rate control. So it took a couple sequences for us to go, man, we're not seeing anything wrong. What's going on? And finally it was like, the rate controller is set improperly.
Something so simple that it's easy to overlook.
And here's the point behind the whole thing, that if you're a pilot and you have most of the PA46s, the latest G1000 NXI and the G3000 airplanes they don't have a rate controller because the Garmin.
Yeah, it's automated.
It's automated.
Yeah.
Every other PA46, not counting the Matrix, every other pressurized PA46 has a rate controller. I would say that's the knob that most pilots don't know what it does. It's the one that no one ever touches, but it's the one that you probably need to do a pre-flight every now and then just to make sure that you look at it. A lot of pilots will put it at 9 o'clock. 9 o'clock's a good number where you're going to get about a 400 or 500 foot a minute descent. But I'll go back to this. It's actually a knob that I want pilots to, on your next flight, look at the rate knob and kind of make sure it's in a good spot. 9 o'clock's a good place to be, but you might think to yourself, well, I only want to climb 200 feet a minute because I want to give my passengers a good ride because I'm only going to 17,000. And that might be a thing you do.
Yeah, and it's something, anytime we test fly one of these things, like if we're going to do an acquisition or buyer agent, as we call it, for our customer, we go test fly, we always make it a point to touch the rate knob.
Make sure it works.
Force the cabin down, make sure it pressurizes. You don't have to climb to 27,000 feet to get the cabin to pressurize. You can turn the cabin altitude
knob all the way down to sea level.
Yeah,
that's right.
And it'll force it up to 5.5 a lot faster, save you lots of time.
Yeah, that's right.
And so we always make sure that functions. And
yeah.
So it's interesting to see for sure.
Yeah, in this case, it's the pilot thought that his airplane wasn't pressurizing, but it was doing what we told it to do. The key is it's just a knob that we hardly ever look at, or most of them. So if you're listening to this, I think the moral of the story is look at your rate knob.
Yeah, and I want to go on another little tangent about pressurization since we're already talking about it. Ideal pressurization, you got one point in which the air comes in, and you have one outflow valve which the air leaves that controls that that rate. The other day we also had a customer come in. He had just again gotten his airplane out of pretty extensive maintenance, and they couldn't get the cabin to pressurize. And this ended up being a little bit different. It came out of avionics. Can you talk about that one?
Yeah. So what happened on this one is that the airplane came out of avionics and somebody had pulled the cabin dump. There's a cabin dump switch in all the PA46s where there's actually two. There's a knob that you can pull that stops the air from coming into the cabin. There's a switch you can push which opens up the safety valve. Mm-hmm. It's basically a switch opens the safety valve. The knob stops the air from coming into the cabin. And this is on jet props and piston, all the piston PA46s. And if you take that knob and you pull it all the way out, and then the cabin will depressurize because you're stopping the air from coming into stopping the pressurized air from coming into the cabin. It's a little more involved than that, but that's enough of a discussion. In other words, that effectively does that. If you pull that knob all the way out and then push it back in, it should reseat. Mm-hmm. I will tell you, it doesn't always reseat well. And so the point that I'm making is that's a knob where somebody in the avionics shop had pulled it out, shoved it back in, but when it shoved back in, it didn't seat properly. Now we went and climbed the airplane. Of course, now what happens is it didn't seat properly, so the dump valve's half open, and the air coming into the cabin just basically dumps out the dump valve.
Right. Not enough air is coming into the cabin to effectively pressurize.
No, instead of saying that none of it's coming in, when you pull the dump knob, the dump valve's it's letting too much air leave the cabin.
Got it.
So you don't have enough coming in to overcome the leak that is occurring. So here's the bottom line. There is a dump valve in all these airplanes. You can pull it. I don't recommend anybody do it. And the reason why, unless your POH tells you that you have an emergency, that the POH is directing you to do it, then I'm totally cool doing it. That's what it's there for. I will tell you, I've never heard of nor ever had it with 10,000 plus hours of flying the PA46. I've never had to pull the cabin dump knob, okay? And I've never heard of anybody having to because of a POH directed emergency. The reason you would do this is if you had bleed air coming into the cabin, or in other words, bleed air from the turbochargers or bleed air from the turbine that was contaminated. In other words, you got smoke in the cabin from either one of those. I've never heard of that occurring. Doesn't mean it can't happen. I've just never heard of it. So the point is there's hardly ever a reason that you would pull that knob. But if you do pull that knob and you push it back in, there's a decent chance that it won't seat well, and you're going to have to take your airplane to maintenance. So don't pull that knob.
Yeah, it seems like most of the pressurization issues we see are simple things. You just go line by line of the few things that might affect your pressurization. You could probably figure it out. Now, the other thing we see commonly is an emergency. A hatch gets pulled for whatever reason, either to inspect it or to provide some more airflow when a maintenance event is happening. And if you don't get that thing perfect, and you have the liner installed inside when you're visually reinstalling the emergency hatch, if you don't hit those little stop blocks, the cabin will not pressurize.
That's right. That's absolutely right. If you look at your cabin pressurization, if you have a problem and you know air's coming into the cabin, you're looking for how is it leaking, door seals, emergency relief or emergency exit not seated properly. There's seals that are around the flight control cables. There's all these little holes that can be the bleed air valve being a little bit open. You're looking for how can the air escape? I'll give you another good one that can happen is the outflow or the safety valve being contaminated, basically having a bunch of stuff not being clean. In other words, you can get lint, and if you put new carpet in your airplane, it's going to shed little things, and if that gets back in your bleed air, back into your safety valve or your outflow valve, it can contaminate that and not seal properly. You're looking for how is air escaping the cabin.
Yeah, that makes sense. Yeah, well, the next question we have is about one of our customers who he bought a Meridian,
right,
and he's been flying it for probably about a year now.
Yeah. And
he's noticing that his start temps are starting to increase. Doesn't matter what the outside air temperature is doing. He did a GPU start at a FBO the other day, 805 on the GPU start, but his battery starts are in kind of the 850 to 860, 65 ballpark. Let's talk about that one.
Okay, and we're talking about turbines here. Just to be clear, if you got a piston, battery condition is important because you want it to start, but it has nothing to do with a dastardly event, which is a hot start. Okay, so really the question is, if you get a hot start in your turbine engine, we're talking about an event that could cost you over $200,000 real quick. And so a good turbine pilot is going to watch every single temperature, every single start to note that temperature and get an idea of the trend of your starts. Now, let's talk about it. When you take the condition lever and you advance the condition lever, you're doing one thing. You're taking fuel and dumping it in the engine, an exact amount of fuel. Okay, it's going to happen every single time, the exact same amount of fuel, assuming your fuel control works properly, almost always does. Okay, so now how hot is your temperature? How hot is that hot start going to be? And the answer is that start is going to be completely dependent upon how much air meets that fuel.
Right.
Okay.
Right.
So because you have an exact amount of fuel, the only other variable in the ratio is air.
Right.
So now, what are going to be the parameters that are going to affect the amount of air coming in the engine? And the answer is hot air density. In other words, your density altitude's high. So if you start your engine in New Orleans, it's going to be a cooler start than if you start it in Aspen, Colorado, because the density of the air, there's more air available in New Orleans than there is in Aspen, Colorado. So naturally, your temperatures are going to be hotter up in Aspen. Okay. Next thing is temperature. If your temperature's cooler, there's more air. So if you're in New Orleans, for instance, and it's 100 degrees outside today, but in some other day it's 35 degrees outside, on the day that it's 35 degrees, you're going to have a cooler start, not because you're starting with 35 degrees, but because the 35 degree is more dense, shoving more air into that engine. So air temperature, air density can be a big player in the equation. Whether or not your airplane is pointed into the wind. I will tell you that on all of the jet props, basically, you can put the ice door to the off position. And now if you point your nose into the wind, you'll get a little bit cooler start because any air that's out there is going directly into the engine and not going into the exhaust. So the turbine can spool up easier with air being shoved into the engine. A good way to denote this is if you start a turbine like a multi-engine turbine. Like I say, I take a King Air and I shut down one of the King Air engines in flight just for training. And then I want to restart it. Well, I've got 100 and probably 30 to 150 knots of air coming into the engine because the engine's dead and the airplane's moving through the air and it's just a lot of air being shoved. That start might be 520 degrees because it's so cool because the start is because I'm shoving all this air into the engine. Even though that start might be at 13 or 15,000 feet, it's a cool start because I'm shoving so much air. The more air I shove into that engine, the cooler that start's going to be. But the number one way to keep a cool start is to make sure your NG turns very fast. How do I make my NG turn very fast? And the answer is a good battery.
Yeah, and let's talk about batteries a little bit because you get options when, especially with the Meridian. The jet props, not so much. Jet prop, you get one battery option, but in the Meridian, we've got two options for battery. You get the RG41, which is the smaller battery as we denote it, and then you have the RG41-53, which is I think it's a 53 amp battery. It's a lot bigger, bottom line, and it has the ability to turn that. Turn the engine faster as you're starting, push more air through it.
Absolutely.
And so, talk about the importance of battery health for us.
Well, it's everything. It's the bottom line. It's everything. When you start your turbine engine, the health of that battery is everything. I say it I say it another way. There's two things on any turbine engine that you do not go cheap on. If it's a PA46 turbine, and that is you don't go cheap on batteries and you don't go cheap on tires. Got a bald spot on your tire, change it out. You only got one tire on that wheel, change it. You want good rubber on the road. But the other one is your battery. I have more pilots with this mentality of how do I get every ounce of energy out of my battery? How do I make my battery last longer? And the answer is I want your battery to last longer. I want it to, but not at the health of the engine. Meaning do things like keep a battery minder and keep it at a good temperature and keep it in a heated or cooled hangar.
A battery minder is going to cost you less than $500.
Absolutely.
And it's going to keep that $7,000 battery healthy longer.
That's exactly right.
And every time you go to start the engine, the battery is going to be at full health because it's slowly trickle charging that battery and keeping it and desulfating it, keeping it at optimum levels.
And that's the more important point is that the battery minder is going to help keep that battery healthy when you're not using it. In other words, a battery that's allowed to dwindle and then brought back up and then dwindle over time is going to be a battery that's not going to be as healthy. And we want to, so the battery minder is going to keep the health of that battery very good. So you definitely, unquestionably, want to make sure that you keep track of keep your battery healthy. But if I have the option of buying a better battery, you do it 100% of the time.
Yeah, you're going to pay a small STC fee the first time you buy that high capacity battery.
Yeah,
but it's a one time $1,000 extra the first time.
That's
but
right.
Every time after that, it's totally worth it. Now, another thing I think a good turbine pilot can do is keep a small notebook in your pocket on the side and write the highest temp and how long did it take to spool up to until you push the condition lever in and keep notes on your engine. There's, from my understanding, not very many easy ways to pull that data. But if you write it in a little notebook, you will know the trend of your engine. And if you're getting the same temp start every single time, your battery's probably staying pretty healthy. Right.
Well, there's a couple of things you need to look at that I recommend. And if you're a new turbine pilot, for sure, you need to correlate a volt, the volts of the battery. In other words, when you turn on your battery switch, look at the voltmeter and make a correlation of the number of volts and how fast your NG is when you hit the start button. So if I've got a battery at 23 volts, then I'm going to expect it to not have turned the NG very, very fast. which is going to mean a hotter start. Okay. So 23 volts equals, I'm making up a number, 13.5 NG. Where if I have a battery that's at 25.7, like a really great battery that's chopped off all the way, it's brand new, you just put it in, it's at 25.7, it's got a lot of volts, that may drive the NG up to 17.5. And the subsequent start is going to be a lot lower. Why? Because it turns it faster. Faster NG means I'm shoving more air into the engine. That greater amount of air meeting that fuel causes the start to be cooler. So correlating a battery voltage to an expected NG speed correlated to a top end speed is something that every pilot should be able to know their particular airplane. Because there are little nuanced differences in the airplanes as far as that's concerned. With some of them have different FCUs, some of them have different tip clearances inside the engine. Some of them are newer engines, some of them are older engines, but you should know what the trend of your engine is. This is one of the trends that I find very few pilots able to make the correlation, and very few pilots know their numbers. So you should be able to look at your battery voltage and say, it's got that battery voltage. And instantly in your brain, you ought to think, okay, I'm on a way to a good start because I got 25 volts. That should be, and in your brain, you might even think, I bet that my NG gets up to 16. And then you push the start button, it goes to 16. And you're like, I'm well on my way to a normal start because things are looking normal. But if I push the button and it goes to 12.5 NG speed, you're probably about to fry your engine. So knowing your numbers is critical.
Yeah. In terms of batteries, how long should I expect my battery to last in a turbine aircraft?
4 years at the most, 3 years normal.
So 3 years, would you say after 3 years I'm on borrowed time? It's ultimately, when's the battery going to die on me?
I want you thinking that. And that basically if you trend a battery tends to go, and then fall off a cliff. And you want to buy a new battery before that thing falls off the cliff. And usually between your third and fourth year is where that battery is going to need replacement. When that battery gives you a signal that it's about time, buy that battery. Said differently, if you go into an annual and you're between your third and fourth year and the guy says, well, I might be able to milk your battery out a little bit if I were to give it some TLC, and just tell him, buy me a new battery. Between your third and fourth year, don't be the proud pilot that says, I'm on my 5th year with the battery because I'm a great pilot, because I promise you that thing's going to fall off the edge of the cliff. You're going to go start your airplane. You're going to fry your engine and cost you $200,000.
Yeah, you're going to get that get home itis. And you're away from your standard maintenance facility and you just want to get home.
Or worse, somebody else is going to start your engine up. The maintenance facility is going to do it. The avionics facility that's just did your whatever. Or you're going to be load up 5 passengers and be distracted during that engine start. Because they're back there talking to you. They don't know not that it's a critical phase of flight. You see what I'm saying? And let me say one more. You know how you can tell where the health of your battery is. The health of your battery can be denoted by assuming you hit your battery switch, you already look at your voltmeter, you know where your volts are, and let's just say they're in a good place, 24 or above. Okay. You can tell how good your battery about how good your battery is when you hit the start button. Your eye should be on the voltmeter. Okay. And if that voltmeter goes below 17, and you had a good battery to start with, in other words, if it goes below 17, you're about to buy a battery. So this is the best way for you to know. You hit the start button, you're instantly giving that, you're demanding a lot, because that starter says, I'll take all you can give me. I'll turn as fast as I can. And the battery's saying, I can't give you any more. The volts go down. If it goes below 17, you are about to buy a battery. There's your answer. So know that, get in the habit of looking at that voltmeter when you hit the start button, because that's it's like riding a bike. If you ride a bike, it's like starting your bike. Like when you hit the battery switch, it's like starting to ride your bike, but you're in 10th gear. It's just hard to get those pedals turning.
You're grinding.
But the faster you go, the easier it gets until you're finally at cruise speed with your bike. Your battery's the identical thing. Matter of fact, if next time you start your turbine engine, hit the start switch, watch that battery voltage, And you're going to note that battery voltage initially takes a huge hit, but now the battery voltage is going to creep up as the start goes. And the reason why is that fuel's now burning in the engine, causing the engine to turn, and it's making it easier and easier and easier on your battery and your starter because the engine begins to turn itself. And so if you notice that, your battery is going to your volts are going to go up as the engine starts because it's easier on that battery. Note that rate of climb. Note how this, you can't do this on your first starts when you first buy a new airplane, but as you become more of a veteran of a turbine operations, you're going to start noting nuanced parts of this, and noting battery voltages whenever you start your engines is a seasoned veteran, a pro, a professional is going to notice these other things, and that's one of the things they're going to notice.
Yeah, and we always say your airplane whispers to you.
It will.
Doesn't matter if it's a piston or a turbine.
That's right.
All these aircraft are going to tell you give you little signals that you need to do something differently.
Right.
Whether that's buy a battery, check a rate knob, whatever it might be.
That's right.
They're going to whisper to you, and it may not be the most obvious thing all the time, but there's going to be a reason something's happening the way it is.
Right. So let's go back to your question. The guy basically says, hey, my start temps are increasing as I go. Could something be wrong? And the answer is yes. What could be wrong? It could be a million things, or it could be dozens of things, of which the biggest culprit is going to be your battery condition. Now, could there be tip rub that's causing the blades to slow down? Could there be an internal problem within the engine that's caused? Could there be something along the lines of a FOD event that's caused some damage within the blades that's causing the air to not flow as smoothly through the engine? Definitely. Can these kind of things occur? But the answer is yes. The number one thing you look for, though, is battery health. If your start temps are going up, check battery health. And then one more thing, and I'll shut up about this, but I guess you can talk a long way about this stuff. When you start your engine 875 ITT, that's the place that you really want to shut your engine down. Now, the book doesn't say that. The book says a much higher temperature. But if you shut it off at a book temperature, then the residual heat can increase past a number, and you're going to end up buying a $200,000 hot section, is going to be what it's going to cost you. And 875 is a good number. And the reason why is if it goes over 875, something's not right. Now, if you're on the top of Aspen Airport, on top of a mountain, and it's 95 degrees outside, it's probably going to be a hotter start. Maybe that day, 875's on the edge of it. But on a normal everyday start, note your start temps. If they get to 875, the entry into the chart is 925. So if you shut off the engine at 875, there's going to be more residual heat that's going to creep up. You're probably not going to get over 925 if you shut your condition lever off at 875. But 875 tells you where it's a Joeism. It's just a thing, a number I pulled out of the. There's just years and years and years of anecdotal evidence that if your engine goes over 875, probably something's not right. If before 875, you're safe. You're not going to enter a chart. You're not going to have a hot start.
Yeah, and this, going back to this one, this guy has a battery that was replaced 3 years ago, and so he's at the limit. And so
he's at the limit.
So buying a battery, I think, is the first step, and then you start recording.
Listen to me, Turbine guys. Listen to me now. I'm going to say it again, but I'm going to say it loud and clear. Don't go cheap with batteries. That's it. I know they're expensive. I get it. Matter of fact, if you think about, let's just say they're $6,000 for a new battery. The good ones are more than that. Turbine, 2 of them for a jet prop is somewhere around the 6,000 mark. Very, very expensive batteries. And if you think they're going to last 3 years, then they're $2,000 per year that you're going to spend in batteries. Just don't be the pilot that's going to, I'm going to eke out that extra year. I'm going to eke out that extra 6 months. Just When you get to a place where there's something with that battery that's signaling that might not be happy, write the check.
All right, Joe. Another question that we often get is especially from a guy that's looking to enter the turbine market, looking to buy his first turbine, and he often says, "Hey, how much is that hot section inspection that they always talk about at the midlife of these engines?" And we typically say it's somewhere in the 30 to 40 range, depending on what they find.
Yeah.
Can you tell us about what that process is when you get a true hot section inspection?
Yeah, when you get you got to think about it. It's hot section, so think of it that way. You have a cold section and a hot section of your engine. It's right between your NG and your NP turbines. That's called the hot section. That's where all the heat is. That's where the flames are. That's where the engine's developing its power. And anytime you have excess heat, that's where the wear is going to occur. Your wear is going to happen where it's hotter. That's bottom line. So when you do a hot section inspection, it's the inspection. That's all it is an inspection. We're merely looking at it. And you're going to take that PT6 engine, you're going to take all the bolts around the whole flange, and you're going to literally pull the engine apart so that you, in one hand, you're going to have the NP section with the propeller, the NP, and then on the other side, you're going to have the NG. All this is obviously staying attached to the airplane, but literally the NP literally comes off. And you're now going to take, from the inside of this engine, they're going to take the hot section of both of these and send them off to a engine shop, and that engine shop's now going to inspect that hot section, and you're going to pay somewhere between $25,000 and $30,000 for the base rate of that to occur. In other words, that's just for them to inspect it. That's what you're going to pay, and you have to pay the mechanic that's going to open the hot section and put it all back together. So you're going to spend $40,000 to $50,000 just base rate, just to make this happen. Okay. And whenever they do a hot section inspection, they're going to do, number one, they're going to look at everything in that hot section because it reveals gobs of what's going on inside that engine. The liner, the stators, the blades themselves. But here's where the expensive part is. And here's why I want to scare everybody if I could, is really what I want.
That's a way to say it.
I do want to scare somebody. Here's what's going to happen is on that NG compressor, if you want to think, your gas generator is what it's called. I think it's 43 blades that are there, a bunch of blades. What you need to think of is 40 plus blades, depending upon the type of engine that you actually have. 40 plus blades. And that engine guy is going to sacrifice two of those blades. He's going to pull those two blades out. And then they're going to cut that blade in half, take that blade to a microscope, and they're going to look under there. Now, if they see heat damage, or let's back this up. If they see no heat damage, they're going to take two new blades and stick them back in where they were, put it all back together, and hand your engine back to you, hand your hot section back to you to put back on. Hot section complete, and everything's good. If they pull off those two blades and they look under the microscope and they see heat damage, you will now buy all of those compressor turbine blades. Those compressor turbine blades are about $2,500 per hit.
I think a set is $115,000.
There you go. Do the math.
I think it's 56 blades, so it's right in that.
It all depends upon the type of engine you got, whether it's Dash 21, 34, 35, 42A. It all depends. But you're going to buy every single one of those compressor turbine blades. And now what they're going to do is they're going to look over here to the power turbine side. And we wouldn't have even looked at these if we didn't have, if all the blades over here were good. But now you're going to go, if all the compressor turbine blades, but now we're going to go sacrifice two of those. So think there's $5,000 because we're now going to sacrifice these two blades. We'll put them under, cut them in half, look under a microscope, heat damage occurs. You just bought a whole new set of power turbine blades. And oh, by the way, if you have, and this is where the end of the trouble has occurred. If you have a Dash 21, 34, 35, you got a jet prop, there's only one power turbine. One power turbine. If you own a Dash 42A, which is going to be your Meridian, M500, M600, M700, you get to now go to the next set because you have a whole nother.
Yeah, you got 2 power turbines.
That's right. You buy all of those blades, you just went well over $200,000. I mean, you'd be $250,000 if you're in a 42A real quick. One hot section, and you will buy all the blades. It is absolutely not worth it. Your enemy, you got 2 major enemies when you operate a turbine engine. That is a hot start, without a doubt, and a FOD incident. Both of those you need to avoid them like the plague. You need to run from them. The best way for you to keep that engine from hot starting is a good battery.
Yeah, and the other thing I think it's so important is good training, because if you get taught correctly how to start it, everything is preventable with good training.
You got a lot of pilots going into deep reverse every time they land, and every time you do it, if you come in and land, that means you're throwing a bunch of crap right up in front of that engine. And the chances of that going into your engine with some kind of a foreign object is pretty high. If you have a turbine, resist the urge to go into deep reverse. I go into reverse just to make sure it's there and I've got it, that I can get over the gate. But if you don't need reverse, you don't need reverse.
You pop into reverse for a second or 2,
right,
and then go back over the gate into beta and use the brakes.
Exactly. It's the bottom line is always be. Matter of fact, it was kind of interesting. We've got a new client that bought a jet prop, and I got to deliver the jet prop to his home airport. Pulled up in front of his hangar. His hangar was a disaster of pebbles, and we literally stood outside of his hangar, looking at the pebbles with a blower as I'm blowing the pebbles all around. You know what I'm saying? And it was like, you've got to get a big blower. You got to buy one, and you got to be fanatical about keeping this ramp clear, because he basically was in an airport with old asphalt and a bunch of piston drivers all around that don't care. But he's the one turbine guy in this, this T hangar complex, and which is great, but there are pebbles all over the place. So that guy's a high candidate, or has a high propensity of getting a FOD event. And so the bottom line is you definitely want to watch out for a FOD event, and you want to watch out for a hot start. Hot starts are the enemy of a hot section inspection.
And that goes back to everything we've already talked about. I appreciate you going down and explaining what exactly happens, because we get the question all the time about what a hot section entails, and that explains it perfectly.
Perfect.
Awesome. Well, thanks, Joe. I appreciate you taking the time to answer these questions for our customers.
Thanks for listening and watching the Malibu Guru podcast. I appreciate you being here. It is my honor to get your question, and the best place to send that is to clint@flycasey.com. Clint Goff's our kind of our digital dude, and he assembles all the questions and pretty much sets up what's happening on the next podcast. So if Clint gets your questions, he'll make sure I get the questions, and we'll consider that on the next one. So we love getting your questions here at the Malibu Guru podcast. Thanks for listening. Thanks for watching. We'll see you next week.